All right, so this is part 2, looking at instantaneous velocity and average velocity word problem. So just to recap, this problem gives an equation for a cheetah's position moving to the right from 1 to 2 seconds. So part B wants us to find the average velocity between T2 and T1. So we have the average velocity formula right here, and we just need to remember that T2 equals 2 seconds and T1 equals 1 second. And in part A, we already got the change in displacement equal to 15 meters. So all we need to do is find delta t. So delta t is equal to t2 minus t1, and then we just plug in t2 and t1, and we get 2 minus 1 equals 1 second. And now that we have the change in displacement, delta x and delta t, we can now plug it into the equation, and we get 15 meters divided by 1 second equals 15 meters per second, and that's our answer. Part C wants us to find the instantaneous velocity at a small delta t. So we're going to need this equation here, and then we're also going to need the position equation that was given in the problem. So the problem wants the instantaneous velocity when delta t equals 0.1. So this is going to be the time interval from 1.1 seconds to 1 second, because 1.1 minus 1 is equal to 0.1. So that would be the proper change in time. So we already saw previously for the x position at 1 second, and we got 25 meters. So all we're going to need to do is find the x position at 1.1. So to do that, we plug it into the x position formula. So we plug in 1.1 seconds for the time, and then we do a couple calculations, and we end up getting 26.05 meters. So now that we have the position at 1.1 seconds, we can plug it into the change in the x position formula, x2 minus x1, end up getting it equal to 1.05 meters. So that's the change in displacement. So now that we have the change in displacement during that time interval, we can now solve for the instantaneous velocity and just plug it into the equation. So we get 1.05 meters divided by 0.1 seconds, and we get 10.5 meters per second for the instantaneous velocity. So now we can move on to part D that asks for the equation for the instantaneous velocity. So to solve for that, we're going to need to use the instantaneous velocity equation that uses the derivative of the position. So then we can rewrite it in this way to show that we're taking the derivative of the x position equation with respect to time. And then we can plug in the equation for x and isolate for each term, and then take the derivative. So the first term is 0 because it's a constant, and then we just have the second term, and then we can isolate just for the independent variable t squared, because that's what we're taking the derivative of. So we pull out the constant to the other side. And then to do this derivative, remember we bring the 2 down, and then we subtract 1 from the 2. So it becomes 2 times 5, and then t to the 2 minus 1. So then we end up getting 10 meters per second squared t. And this would be the instantaneous velocity equation. So we can use this equation to find the instantaneous velocity at really any time. But the question asks for t equals 1.0 seconds, so we can plug that in for t. And we just get the answer equal to 10 meters per second for the instantaneous velocity at 1 second. And then I just have one note regarding the equation with the limit. Since we made delta t equal to 0.1, we can neglect the limit as delta t goes to 0 because delta t is small. So if it just looked like it disappeared in our example, that's why. It's more just a formality.